This video will discuss about Physics Paper 2 S Level Structured Question 2016 October November 21 9702. Define density. Density is the mass per unit volume. The mass m of a metal sphere is given by the expression where rho is the density and d is the diameter of the sphere. Data for the density and the mass are given in table figure 1.1 where rho and m we know the value and its uncertainty. Calculate the diameter. So to calculate the diameter, we need to use this expression and make d become the subject of formula. Then we place the value of d and m, and we know the value of pi, that is 3.14, and use it to calculate the diameter as 0.121 meter. Use your answer in 1 and the data in figure 1.1 to determine the value of d with its absolute uncertainty to appropriate number of significant figures. So from the figure we know that the percentage uncertainty in rho and percentage uncertainty in m. As we know that the percentage uncertainty, we first find the percentage uncertainty in d. Percentage uncertainty in d is equal to percentage uncertainty in m plus percentage uncertainty in rho into 1 by 3, because there is a power of 1 by 3. So after multiplying this, we get a value as 3%. So 3% is the absolute percentage uncertainty for d. As we know the percentage uncertainty, we can calculate the absolute uncertainty by approximate change in d by d into 100%. Then we use this expression to calculate our approximate uncertainty or absolute uncertainty in d, that is 3.63 into 10 to the power negative 3, or approximation to 0.004, and then we write our answer as 0.121 plus minus 0.004 as our final answer. So as we are given the percentage uncertainty, so first of all we have calculated the percentage uncertainty, then approximate change in d or absolute uncertainty in d divided by d into 100% is equal to percentage uncertainty. Then we calculate the absolute uncertainty and write our final answer as given. Then in question number 2, as electric field is removed from our syllabus, so we are not going to discuss this right now. Also this page is from electric field. Then question number 3a, state Hooke's law. Hooke's law is that force is directly proportional to extension provided that limit of proportionality is not exceeded, and force is directly proportional to extension. That means load extension graph would have a straight line with a constant gradient. The variation in compression x for the force F acting on the spring is shown in figure 3.1. So it has a constant gradient. The spring is fixed to the close end of a horizontal tube. The block is pushed into the tube and then the spring is compressed. So as the block is pushed, the spring is compressed, and shown in figure 3.2. So this is shown. The compression of the spring is 4 cm, or in meter 0.04 meter, and the mass of the block is 0.025 kg. Calculate the spring constant for the spring. So spring constant is the force per unit extension, that is force divided by extension, force in Newton and extension in meter. We get our spring constant as 600 Newton per meter. Then show that the work done to compress the spring by 4 cm is 0.48 joules. So from graph, as we can see that work done is equal to force into distance. So from graph, the graph of force into distance, or force against distance, is the work done. So as this is a triangle, so work done is equal to half force into distance. But if it would be a rectangle, then the graph would be fx. But as it is a triangle, and since y-axis and x-axis both multiply to give our work done, and since this is a triangle, so we have to multiply this with half. This is a very important part that we need to remember. So work done is equal to half force into distance, that is half fx, and we calculate our work done as 0.48 joules as shown. The block is now released and it accelerates along the tube as the spring returns to its original length. The block leaves the end of the tube with a speed of 6 meters per second. Calculate the kinetic energy of the block as it leaves the end of the tube. We know that the kinetic energy is equal to half mv square. So half mass of the block is 0.025 and V is 6. So half mv square is equal to 0.045 joules. 0.45 joules, not 0.45. Assume that the spring has negligible kinetic energy. So for the spring to have a negligible kinetic energy, as the block leaves the tube, determine the average resistive force acting against the block as it moves along the tube. So it mentions that as it leaves the tube, the spring has negligible kinetic energy, while as it leaves the end of the tube, it has kinetic energy plus some resistive force acting on the block. So we need to calculate this resistive force. So to calculate this resistive force, we have given the initial energy or initial work. We have given that the initial energy that is work done when compressing is equal to final kinetic energy plus work done due to resistance. We know that the work done due to initial energy, that is 0.48, and kinetic energy, that is 0.45. Thus we can calculate the work done against resistance, that is 0.03 joules. As we know that the work done is 0.03 joules, so we can calculate the force due to resistance, that is work done by distance. Work done is equal to force into distance, so force would be work done by distance, that is 4 by 100. So resistive force is 0.75 Newton acting on the block due to its exciting movement. Now determine the efficiency of the transfer of elastic potential energy of the spring to kinetic energy of the block. So we need to calculate the efficiency. Efficiency is the useful energy output, that is the elastic energy or the kinetic energy divided by total energy into 100%. So elastic energy is 0.48, kinetic energy is 0.45 into 100%. We get our answer as 94% efficient. State what is meant by frequency of a progressive wave. Frequency is the number of complete waves or wavelength produced per unit time. Frequency is the number of complete waves or wavelength produced per unit time. A cathode ray oscilloscope is used to determine the frequency of the sound emitted by the loudspeaker. The trace is produced on the screen of the CRO is shown in figure 4.1. The time-based setting of the CRO is 250 micrometer. As we know, the value of micro is 10 to the power negative 6. Show that the frequency of the sound wave is 1600 Hz. So for this wave, we have to first determine that when a wavelength is completed. So we can determine by using the phase that is, or using the waves that are in phase, and we can calculate this such as the waves that have, or the points that have same displacement and same direction of motion. So this point and this point have this point or and this point have same displacement and same direction of movement, that is upwards. So the distance between these 2 points is 2.5 boxes, and one box is 250 microsecond. So 2.5 box is 2.5 into 250 into 10 to the power minus 6. Then frequency would be 1 by time period, that is 1600 Hz. The loudspeaker in B emits sound in all directions. A person attaches the loudspeaker to a string and then swings the loudspeaker at a constant speed in a horizontal circle about his head. Suppose this is a person and it attaches the spring to a string and then circles it around his head. Then an observer standing at a large distance away from the loudspeaker hears maximum frequency. For a maximum frequency, the denominator has to be less. Thus, we have to place a minus at the denominator, and if it be a minimum frequency, then we have to place a plus at the denominator. For a maximum value, denominator would be less. So determine the speed of the loudspeaker. So as maximum frequency is observed, so Fo is equal to Fsv, V plus minus Vs. But as we had a maximum frequency, so we have a denominator with a minus sign, not a plus sign. And then we calculate the value of the speed of the loudspeaker or speed of the source as 8 meter per second. Describe and explain quantitatively the variation in the frequency of the sound heard by the observer. So as we can see that it moves the string around a horizontal circle. That means if an observer here hears the sound, then when the string is here, he hears a maximum frequency of sound, and when the string is here, he hears a minimum frequency of sound. So the loudspeaker is moving around towards the observer, causes a high frequency sound that is towards the observer at this point, and moves away from the observer, that is at this point he hears the minimum or lower frequency of sound, and this occurs repeatedly. State what is meant by diffraction of a wave. So diffraction is the spreading of a wave into a geometric shape. Spreading into a geometric shape as it passes through an edge or an obstacle. Laser light of wavelength 500 nanometer is incident normally on a diffraction grating. The resulting diffraction pattern has a diffraction maximum up to and including the fourth order maximum. Calculate for the diffraction grating the minimum possible spacing or the value of d, that is minimum. So we know that the equation d sine theta is equal to n lambda, where n is the number of waves, lambda is the wavelength, sine theta is the angle, and d is the slit spacing, or the difference between the slits, so or the line spacing. So for a value of d that is minimum, we need to take the value of sine theta that is maximum. So value of sine theta would be maximum when the value of theta is 90 degree, because when sine theta is 90 degree it has a maximum value of 1, otherwise we would get a minimum value such as 0 for 0 degree and 0.7 for 45 degree. So for a value of d that is minimum, we need to take the value of sine theta that is maximum, that is 1. So we put the value of n, that is fourth order maximum, so 4 into wavelength 500 nanometers, so we multiply it with 10 to the power minus 9 divided by sine 90, we get a value of line spacing as 2 into 10 to the power minus 6. The light in B is now replaced with a red light. State and explain whether it is likely to result in the formation of a fifth order maxima on the diffraction maximum. So we need to find whether red light would form a fifth order maximum. We know that the equation d sine theta is equal to n lambda. Thus, if we increase the value of lambda, the value of n would decrease, since n and lambda are inversely proportional to each other. So, as red light has a maximum wavelength, so the value of n would be minimum. And since the value of n would be minimum, so instead of 4, it could be 3, 2, 1, or no value of n, that means no waves are formed. But it could not be a greater value, since we use the value of lambda that is greater. As we increase the value of lambda for the red light, the value of n should be less. So we cannot get a fifth order maximum, as lambda of the red light is greater and the value of n is inversely proportional to lambda, so fifth order maximum cannot be formed. Define electric potential difference. So potential difference or electric potential difference is the work done in defining a unit charge around a complex circuit. A battery of EMF 14 volt and negligible internal resistance is connected to a resistor network as shown in figure 6.1. R1 and R2 are fixed resistors of resistance 6 ohm and 12 ohm respectively, and R3 is a variable resistor. So R3 is a variable resistor. We have to remember this statement that switch S is closed. So switch S is closed. For this question we have to consider that switch S is closed. Okay. Calculate the current in the battery when the resistance R3 is set to 0. As the resistance of R3 is set to 0, that is 0 ohm, so as the resistance is 0, full current would flow through here. So full value of I would flow through here and no value of I would flow through R2, because as the resistance is 0, current would have a maximum value. Thus, as current has a maximum value, so current would not flow in resistor R2. Thus, we have to take the value of resistance as 0 ohm. So to calculate the value of current is equal to voltage by resistance. Voltage is 14 ohm and resistance is R total, that is the value of R1, that is 6 ohm, and the value of R3, that is 0 ohm. 0 ohm because it is given that R3 is set to 0, so 0 ohm, and there is no current is flowing because since resistance here is 0, so all the current would flow through R3 and no current would flow through R2, as resistance is inversely proportional to current. So current would be voltage by resistance, that is 2.3 ampere. Then resistance is 24 ohm, So now we have to consider the value of resistance as 24 ohm. Since it is 24 ohm, that means it has some resistance. R2 would also have some resistance. Since both have the resistance value, so the value of R total would be 6 arranged in series plus R2 and R3 which are arranged in parallel. So 1 by R2 plus 1 by R3, that is 14 ohm. Since we know the value of resistance and the value of voltage as 14 ohm, 14 volt, and the resistance is 14 ohm, we can calculate the current, that is voltage by resistance, that is 1 ampere. Use your answer from B1 to calculate the change in total power produced by the battery when the resistor R3 is changed from 0 to 24. So R3 is changed from 0 to 24. We need to calculate the change in power. And as we know that when a resistance or current is changing, we can use this equation, power is equal to I square R. So change in power would be change in I square R. That means the initial I square R minus final I square R. So for this, we know that the initial value of current and initial value of resistance. We also know the initial value of final value of current and final value of resistance. Initial value of current is 2.3. Initial value of resistance is 6 ohm for 0 ohm for R3. And final value is 14 ohm and current is 1 ampere for 24 ohm of resistance of R3. So for the resistance of R3 from 0 to 24 ohm, that is current from 0 to 24 ohm, we know the value of current and resistance for both of this situation. Thus we can calculate the change in power as 19 watt. Now we have to consider that switch S is now open. Since switch S is open, so we can now thus ignore the part R3. Since switch S is open, we can ignore this part because this is no longer be used, and all the current passes through R2 and no current passes through R3 since switch is open. So for the switch is open, determine the ratio of average drift speed of free electrons in R1 by average drift speed of free electrons in R2. We already know the value of cross section of R1 and the cross section of R2 and the value of N for R1 and R2. So we can use the equation I is equal to N AVQ. Then we rearrange this equation, and as we know that the value of current is same for both these resistors since they are arranged in series, and also the value of Q, that is 1.6 × 10 to the power minus 19 coulomb, is same for both this equation. Thus if we arrange the equation, we get a overall equation as nR2 into AR2 by nR1 by AR1. Then we place the value of nR2 AR2 by nR1 by AR1 to calculate our ratio as 0.90. It would be better to give 9:10 since this is ratio, not a value. This would be better to write this instead of this. Then question number 7. Here particles are divided into leptons and hadrons. Hadrons is the head of the second group containing mesons and baryons. Leptons are not made of quark. Hadrons are made of quark. Thus, as leptons are not made of quark, they does not express or experience any strong nuclear force. But as hadrons, mesons, and baryons are made of quark, they experience a strong nuclear force. State one difference between hadrons and leptons. Hadrons are made of quark, but leptons do not. Thus, hadrons experience a strong nuclear force. State the quark combination of a proton and a neutron. Protons are made of up and down quark, while neutrons are made of down and up quark. Use your answer in 1 to determine the quark composition of an alpha particle. Alpha particle is similar to a helium nucleus containing 2 protons and 4 nucleons, that is 2 protons and 2 neutrons. So we know the quark composition of protons and neutrons from above. Thus we can calculate the quark composition or the number of up and down quarks, that is 6 up quark and 6 down quark. The result of alpha particle scattering experiment provide the evidence for the structure of atom. The vast majority of alpha particles pass straight through the metal foil or are deviated by smaller angle. A very small majority of alpha particles are scattered through angles that are greater than 90 degree. So this for experiment 1 or result 1 and 2, most of the alpha particles passes straight through without any deviation, and in result 2 some of the alpha particles are deviated. So what can be concluded or inferred from result 1? As from result 1 we can see that alpha particles passes straight through as the alpha particles passes straight through, that means most of the atom is empty space. And in result 2, some of the alpha particles are deflected by a larger angle. This is because the nucleus is charged, or there is a small nucleus inside the atom, since only some of the alpha particles are deviated, not all. Thus, a small area is covered by nucleus, there is a nucleus, or the mass is concentrated in a small nucleus, or nucleus is charged since the alpha particle or a charged particle is deviated.